topic is Fibre Channel 0 to 256. So as the name describes, there's a big gap between where it started and where it is today, or where it's going. So we're going to discuss that quite a bit. This actually is an FCIA partner presentation with SNIA. So my name is Mark Jones. I'm representing the FCIA today in this presentation, and we'll get with it. Okay, so there's a couple of milestones within the FCIA that we're going to talk about as we get into this presentation. And just to kind of set the stage where things are today, there's Fibre Channel is very strong and really doing well. We have, from the right side, we have over 160 million ports of Fibre Channel that have been shipped into the industry, with about 35 million estimated in service today. So if you're involved with enterprise storage, you know that it's mostly connected with Fibre Channel, and it's still going very strong. In terms of revenue, if you are a company developing products with Fibre Channel or Fibre Channel products, since the beginning that we've been keeping track of these numbers, it's over $50 billion in manufacturer revenue for Fibre Channel products. So it's still strong, it's still going good, and it's very viable. Kind of looking back at some of the history, this arrow usually didn't go as far a couple of years ago, but we keep growing and keep adding more speeds to it. You can see we started back in 1988, where the standard first was developed. That's where work first began on Fibre Channel. Then our first ship product was probably officially 1 gig Fibre Channel. And then every 3 to 5 years, we've added within the industry, we've doubled the performance of Fibre Channel, 2 gig, 4 gig, 8 gig. We're shipping 64 GFC Fibre Channel today, and we have a couple of other variants of Fibre Channel in the works that I'll talk about in a second. But it's not just the speeds and feeds. There's been a lot of other really interesting things that have happened in Fibre Channel to keep it really viable in the industry. We originally started with arbitrated loop technology. That quickly was replaced with fabric services, and how great that's been since fabric services, everybody relies on it, and it really helps figure out a very large-scale network fabric with storage devices. Virtualization with NPIV. NPIV is still used a lot today, especially in storage devices. Autonomous SANs, with fabric notifications and everything that can be done in the analytics of what's being tracked within the fabric. We actually can act upon that with and actually help heal certain problems in the fabric. And then NVMe over fabrics using Fibre Channel over Fibre Channel. So we've mapped the Fibre Channel protocol to NVMe over fabrics, and that's pretty much shipping on all flash storage arrays today. And then working into encryption, so in-flight encryption over Fibre Channel. There's a lot of activity in the standards organizations regarding security, and we'll talk about that in a moment. Okay, so where are we at as far as, I mentioned all these different speed changes in Fibre Channel. We have a lot of data that goes all the way back to, I believe, 1988 with Deloro data that we can access. And it's really interesting to see that when one speed enters the marketplace, that the previous speed starts to compete with that, and the new speed accelerates in adoption while the old one tails off. And when we have so many variations of speed that changes every 3 to 5 years, you really can see how one takes off while the other dies down. And so we actually have a forecast from the Quillen group looking out over the next couple of years, looking forward. And you can see that today that 8 gig Fibre Channel is pretty much going away. 16 gig Fibre Channel is being shipped less and less. It's almost gone. And for the first time, 64 gig Fibre Channel is just about ready to cross over at 32. And the continuation continues to happen in this fashion. One major point, and I'm sorry, there's supposed to be some words on the right-hand side that didn't show up, but this is a press release from the Crehan Group, that is looking at 64 gig fiber channel, 64 GFC, and they've noted that 64 GFC is actually doing much better compared to in adoption compared to 32 GFC, stating that it's actually been adopted quicker in terms of revenue by HBA ports when compared to 32 gig. And there's a couple of reasons for that. A couple of things are, there's a lot of 64 gig fiber channel switch products shipped into user environments. So that primed the pump for HBA sales and server sales with 64 gig HBAs. So all the last generation servers all were capable of shipping with 64 gig HBAs. And then the price points have been held very close to what 32 gig was. Hey, my word showed up. I guess it's a build slide. Okay, so why Fibre Channel? So you may be wondering, well, it's all doing good, but why is it doing so good? And there's a lot of good natural reasons why Fibre Channel does so well. It's designed for enterprise storage. Nearly all flash storage arrays use Fibre Channel. Security, and the comment there is, not to say there's anything bad about Ethernet, but it's not Ethernet. It's on a different network. It's separated. There's air gap between the two. And that gives some folks a peace of mind that when it's their most critical data in their enterprise, that Fibre Channel is the most secure protocol for that, just being that it's separated. There's also the security brought about by what's happening on the switch side of things with the hardened zoning and fabric services. And we're working, as I mentioned, on a new security protocol, FCSP3, and that's going to have automatic encryption, and it just enhances the Fibre Channel security even more. Performance, Fibre Channel is actually very low latency. Maybe a lot of people don't give it credit for that, but it can be as under 10 microseconds for a full 512 byte round trip I/O. Very low CPU utilization on the host side because most of the Fibre Channel HBAs are offloaded, and very high IOPS. Some HBAs are over 15 million IOPS these days. And also very high fabric utilization. Due to its lossless configuration, it can sustain very, very high I/O rates without retransmission or much effect on performance. Reliability is a big deal. Lossless, credit-based transmission, very, very low bit error rate on the network. That's by design. And of course, part of the popularity with Fibre Channel has been every time we go to a new speed, there is an investment protection built into its backwards reliability. So all Fibre Channel new speed standards are specified to be at least 2 generations backwards compatible. And we've also been very fortunate to keep the cabling and even the connectors pretty much standard ever since 2 gig Fibre Channel. So that allows folks that have invested, let's say, in a flash storage array a couple years ago to upgrade to the latest 64 gig Fibre Channel switch or HBA, and all these things can kind of play together still at the highest permissible speed that everybody can operate in. So it allows for people to step into upgrades to take advantage of the new technology. Okay, so now I'm going to mention a couple of developments that are happening within the standards organization in Fibre Channel. One of those is the next speed, FCPI8. This happens in Insight's Fibre Channel. It used to be called T11. I believe the T11 name is kind of going away and not being mentioned much, except privately. But so it's Insight's Fibre Channel. So FCPI8, this is the 128 GFC speed. That standard is completed. It was completed in December 22. Its goal at the time was to be the fastest single lane speed for Fibre Channel, at least until 250, till the next speed gets here. And intention was to double the bandwidth, the available bandwidth as seen on the wire from this previous generation that was 32 gig. And so it also is 2 generations backwards compatible. It has that investment protection built in. It can use existing cable assemblies like LC connectors and SFP plus form factors. And it is very capable in the data center to reach 100 meters in multi-mode configuration and 10 kilometers in single mode. So that specification, as I mentioned, was completed in 23, and we're going to see products in the marketplace very soon. Not yet, but very soon. There might be some test equipment products that are getting there. We'll probably see, the traditional switches probably first, and the HBAs, and then storage arrays, and then we'll start the whole cycle over again the next time. Okay, the next one, and the tagline for this presentation today is 256 GFC. That is in development. There are people working on it. When Insight's Fibre Channel group meets face-to-face, there are, I don't want to say a packed room, there is a room of engineers that gets together, and they're diligently working on all the issues that it takes to come up with the fastest single-lane speed for storage. And that's 256 GFC. It is not 200 gig Ethernet. It is distinctly different than that. And it again doubles the bandwidth from 128 GFC. It maintains that backwards compatibility feature that I mentioned, and same with cabling. It's expected to maintain the same kind of cabling. The distance is a challenge. That's what the team's working on, is trying to get the full 100-meter distance in the data center in multi-mode. That technology is, when you get in the upper speeds, it becomes very difficult to do, but they're hopeful they can get there. So I'm sure they will. It uses the PAM 224.4 Gbps speed. And we're expecting that to be done fully technically defined at the end of 25, publication sometime in 26, probably by the end of 26. And market availability is going to be, what the market decides, but we're estimating around 2029 probably. So that's 256G Fibre Channel. There are other things being developed, and there's one I can give you an update on. That's NVMe over Fibre Channel, NVMe over Fabrics using Fibre Channel. We started on that work in Insight's Fibre Channel back in 2014, and that group was called FC-NVMe. And there was a lot of work done there, a lot of industry stuff we had to do together, like plug fests and events and standards development and all that. But it finally reached production, and it's pretty much shipping by all major storage array vendors today. All the big enterprise storage arrays are pretty much shipping NVMe over Fibre Channel today. You see that almost everywhere. It's in all the major operating systems for the enterprise. Let's see. Yeah, so there's some very distinct performance improvements with NVMe over Fibre Channel. We're seeing it a lot where any place, because usually there's still regular FCP Fibre Channel available as well as FC NVMe available from the host and the storage array. And where you see the performance improvements is any place where you have a very highly threaded application, something like databases, for instance. Databases are running OLTP type transactional data with lots of clients connecting into it. The highly threaded nature of NVMe FC really lends itself to that. And you literally get something for nothing when you use NVMe over Fibre Channel in this environment. It improves the performance of databases. Okay, and finally, the last major thing that's being worked on, and this is really a major project that's really developed in the last few months within the standards organization, is FCSP3. That's the security protocol for Fibre Channel. It's the third one. And it updates the standards for Fibre Channel security. The main mission here is to stay ahead, to keep Fibre Channel ahead of the requirements by the governments that are imposing stricter security protocols on networks, especially very critical data networks that the governments use. And this program also eliminates outdated security algorithms that were in previous versions of the Fibre Channel security protocols, clarifies the implementation of some of these profiles as well. It adds definitions for CNSA 1 and 2 algorithms, removes MD5, SHA, and others, and it develops a suggestion and a profile and an annex for an automatic in-flight encryption. So imagine in-flight encryption just being automatic and not having to really worry about it from a administrator point of view. Where is it? So the technical definitions are well underway. There's a lot of meetings taking place right now, and there's a lot of progress happening. We expect the definitions to be done by the end of this year, and the full standard completion, full publication by the end of 2025. There will be products that will be in the marketplace in 2025. So you'll see 64G products that will have the capability to have full end-to-end encryption in 2025. Okay, I'm getting the 10-minute signal, so I gotta move it along. So just to go a step deeper on this topic, so in terms of what's the need for this and what's happening, so the big wake-up call was back in 2020 with the SolarWinds security event. You may have heard about that. It left a lot of government servers and organizations kind of flat-footed and exposed, and it became a big reason to react. And the government in the next year, established executive orders to improve national cybersecurity. And we have to pay close attention to what's going on here. Some of those things were, zero trust architectures, and they defined CNSA 1.0. Other governments throughout the world kind of followed suit or came up with their own ideas, EU being, and the UK being very strong there. In 2022, quantum resistant algorithms became a big talking point. So CNSA 2.0 was suggested, and really suggesting that encryption needs to be everywhere it can be. And then in Europe, the Cyber Sea Resilience Act, it brought about EU requirements for hardware and software for encryption. So that, there's one thing where the US has our rules, but in the EU, they have their own things that are much more. It gets down to the corporate level. And so if you're a bank and if you don't choose the most secure method of storage networking and you get hacked, if you're the CIO, you could be held personally responsible. So it's a little different world over there. And that's the kind of thing that they're really reacting to. And everything is setting up now for a lot of these rules getting in place and being suggested to be in place by 2025. And 2030 is going to be the time for the real requirements. So it's time to react now to be very secure. And Fibre Channel, of course, being thought of as being the leader in storage security, is going to make sure that we're well ahead of that. Here's an example of the in-flight encryption, the automatic encryption I talked about. It's very simple. Each HBA on the host side and on the storage array side already do have manufacturer certificates built onto the cards. And during the login process, they'll exchange information and authenticate. They'll establish random session keys. They'll set up a fully encrypted data in flight. And this will work across SCSI, NVMe, FICON, and it'll be fully interoperable. So these kind of things will be standard product offerings in the next generation of servers coming out. It'll be automatic, so there's no external key management, no external software, no drivers, special drivers to load. It's all going to be part of the hardware. It'll be very simple key management. There'll be no impact on performance. It'll preserve many of the storage features. And this is a very big deal if you're an array manufacturer and you have compression and dedupe features or ransomware detection features that if they see a block of data coming into them that is already encrypted, they can't do anything with it. You can't compress it anymore. If it's ransomware in there, they can't detect that it's ransomware. So they need the data coming in to be, when it gets to them, to be unencrypted, meaning that when it gets to the interface on the array side, it needs to decrypt it before it goes into that compression engine. So there's a big value proposition there. And it preserves, all the typical Fibre Channel paradigms, zoning, fabric services, and all that. So that's it. It should be, like I said, it should be in the marketplace in 2025. We'll have the standard done by the end of next year. Okay, another thing that the FCI does a lot of is education. So, the FCI, Fibre Channel is not being taught in schools very much anymore. It's kind of just expected that corporations know this stuff, but there's new talent always coming in, of course, and they need to be trained on that. And one of the FCI's missions is to provide a lot of special education very specific to Fibre Channel. So if you'd like to see some of that, we have a Bright Talk channel with a link there. The FCIA also has a YouTube channel that I encourage you all to go to look to see some of these courses. And then if you want to participate with us, go to fibrechannel.org. We have lots of content there. And then we have some social media links in there as well. All right. Well, is there any questions from anybody regarding Fibre Channel? All the data that your company needs for AI is going to come out of that gold that's under the Fibre Channel network. All right. Well, everybody, thank you so much for attending. I think it's going to be a break time now. So thank you so much.